Good day, Madam Sharina. I'm Pritesh here, and today my group mate Young and I, we will be presenting our new sheet topic, which is a new process to store CO2 into concrete. So let's jump into it. First, we got our introduction. So, from me personally, a team of engineers developed a new way to inject CO2 into concrete where they use carbonated water instead of using still water during the concrete manufacturing process. So this is the article, and these are the key concepts that we finally got achieved by using the Google. First, I want to talk about the development itself, where the researchers they develop approaches that lower the CO2 emissions. For example, this system could turn the cement and concrete a carbon sink product where they can trap and absorb CO2 in a high. In addition, the Northwestern researchers also leveraged the fresh concrete carbonation process because when we inject CO2 into water mixed with small amount of concrete, the cement suspension carbonation is much lower viscosity compared to the mix of water. So this will increase the rate of reaction. And this is the comparison between old method and also new method. In the old method, they used hardened concrete carbonation, where the workers will inject CO2 gas into the concrete block itself at higher pressure. And another one is fresh carbonation, where workers inject CO2 gas into mixture of water, cement, and lot of things. But these two processes cannot absorb CO2 at higher level. But now the researchers develop a new system to inject gas CO2 into water mixed with small amount of cement just to make this a carbonated liquid cement suspension, and this can absorb and trap CO2 for a longer time. And the impact from this development is that the greenhouse gases can be reduced because the system itself can capture and store CO2 as calcium carbonate. At the same time, we can turn a harmful gas like CO2 into a useful building material. This is because concrete consists of calcium silicate. So when we inject CO2 into concrete, CO2 will react with concrete calcium silicate to form calcium carbonate, which is a tiny pore crystal fill all the pores and cracks inside the concrete, making it so stronger. And finally, we can achieve a long-term and economic benefits because higher CO2 storage efficiency can reduce taxes for future carbons. At the same time, it can reduce the environmental penalties for the construction companies. And another key concept is application and limitation. First application is that it could be used in beams, slabs, columns, and everything we use concrete for. So this shows that the new system can be applied in a lot of sectors that use concrete. Another application is that since we are using the suspension carbonated cement, we can increase the rate of this reaction, and at the same time we can provide opportunities for engineering new clinker based products where carbon dioxide becomes the key ingredient for that. And this is also dedicated to sustainable construction. But the limitation here is that these carbonation approaches, there are rumors that the strength of it often affected by the chemical reactions, and at the same time there is no lot of reliable proof to make sure that this system can absorb more CO2. I mean, we have tests, but the tests are not reliable that as we need more proofs. The impact from this is that it allows large-scale adoption in construction company. At the same time, this system has the ability to turn concrete into a carbon sink that can trap and absorb CO2 for a longer time. And this supports the global goals for sustainable infrastructure and climate change mitigation. And finally, this new system can create opportunities for new innovation in the future where all the innovations could optimize the use of CO2 and reduce the greenhouse gas levels in the atmosphere. I'll pass it to you, Yong. Thank you.
Thank you, Pritesh, for the amazing output just now. Now I'm going on for the third segment of our presentation today, which is the influence. So first of all, I would like to talk about the governmental actions. First, we would mention about the national targets set by governments, whether it's governments in Malaysia or governments in other countries. It's to mitigate global warming. For example, in Malaysia, our government plan to achieve a 45% reductions in carbon intensity by the year 2030, and so is India. And Second one, we have funding and subsidies to really achieve the targets that I mentioned just now. For example, we have the US Department of Energy, DOE, which they have invested a lot in via the industrial demonstrations program to company like Heidelberg Materials Cement Plum to really boost the project, the carbon mineralizations project. And yeah, there are some statement about Malaysia, India, and also the US. And the third one would be the international corporations, because we have a lot of agreements and memorandum of understanding (MOU) signed, like the Paris Agreement. We also have governmental level agreements, like the CCS MOU between Malaysia and Singapore. And we also have governments participate in major global forums like a World Economic Forum. And the fourth one is the procurement policies. The first one, the CCUS Act 2025, is a rather new established act in Malaysia. And if you were to like to gain more information about it, you may scan the QR code appear on the screen. And the second one, the green investment strategy. And the third one, tax incentives. And those three aspects of policies would certainly boost the project, the carbon mineralizations project. So they are proof to what I've said just now. Yeah, the screenshot of the newly passed bill, the CCUS Act 2025. And second one, I would like to mention about the organizations. So the first one, setting roadmaps and targets. For example, some organizations like Global Cement and Concrete Associations (GCCA) have set targets like net zero carbon dioxide emissions by the year of 2050, and so is UN. The United Nations have set such sustainable development goals. For example, the SDG 7 and also 13. And next, we have global forums which involve multiple stakeholders. For example, like what I said just now, the World Economic Forum (WEF), through initiatives like the First Movers Coalitions aggregates private sector demand for the low carbon products, which the low carbon products also include the carbon mineralizations project, like what we discussed about it today. We also have Mission Possible partnerships, which have collected about 1.42 trillion US dollars for concrete transitions by the year of 2050. That's such an amazing number, yeah. So there are some statement proofs about what I've said just now. So last but not least, we move to the fourth part, which is the last part of our science as human endeavor, communications and collaborations. So the first one, communications. We have such amazing researchers all around the globe. And what makes the researchers work together is through research and also research. For example, the research that we make it as our main material to discuss about it today is written by Fu et al. 2024. And this research has resulted in a more efficient carbon dioxide sequestrations of up to 45%, and this is such an amazing result. And in terms of collaboration, we also have communications among cross-industry networks. We have Innovandi Global Cement Concrete Research Network, which is a part of initiatives of GCCA. And this would certainly bring together scientific institutions from all around the globe. And if you want some data about country specific, we also have in India and UK, for example, the project like the Maple Creek Consortium in United Kingdom. We also have project design process, which involves AEC firm, the architecture, engineering, and constructions. We also have innovative technologies like carbon dioxide mineralizations, like what we discussed about it today. And the last part, and there are some proof about what I've said just now. And the last part will be the global and knowledge collaborations. We have global roadmaps like what I've said just now. So the Global Cement and Concrete Associations collaborate with bodies like the Clean Energy Ministerial to launch such amazing CCUS initiatives to really establish and communicate a clear roadmap and also targets. We also have International Energy Agency Greenhouse Gas R&D program, which is critical for sharing lessons learned. And the last one, standardizations. We need standardizations to really ease things out so that industry would face a lot of problems when we want to make such amazing projects like the carbon mineralizations project come into true. Yeah, that will be more easier for them. So there are some proof the what I said just now, and that's all. Thank you from me and also Pritesh. You may scan the QR code if you want to gain more information about the research that which is the main material of our discussions. Thank you.